Okay, so we're going to be doing solving systems of equations by elimination. So we're going to go through a few questions, and then we're going to have a question in which we explain in further detail. But let's begin and let's start. So we have question 1 is solve each linear system. And again, this is going to be doing we're going to be solving by the method of elimination. And let's begin. So what we want to do is we want to eliminate the x variable by subtracting equations 1 and 2. So let's do that. So we've eliminated the x variable by subtracting equations 1 or 2, and we are left with 2y, and we are left with the y variable, so we're going to follow order of operations to isolate y. By doing this, we have calculated the y coordinate at the point of intersection. So we're going to choose either equations 1 or 2, and we are going to substitute the y coordinate of the POI into the equation to get the x coordinate of the POI. So we substituted y equals -1, so the y coordinate of the point of intersection, into equation 1, the original equation given, equation 1, to calculate the x coordinate of the POI. So we have our therefore statement saying the point of intersection coordinates are 4 and -1. Moving on. So again, we eliminate the x variable by subtracting equations 1 and 2. So we follow order of operations to isolate y, calculating the y coordinate of point of intersection. Calculating the y coordinate of the point of intersection. So we're going to substitute our answer, the result of the y coordinate of the POI, into equations 1 or equation 2, in this case equation 1. So we followed order of operations to calculate the value of x, and this value of x is the x coordinate of the point of intersection, and now we're going to do a therefore statement. Excellent. Moving on. So are going to eliminate a variable by subtracting equations 1 and 2. In this case, the variable we're eliminating is x by subtracting equations 1 and 2. We're going to isolate the remaining variable to find the x or y coordinate of the point of intersection, or POI. We're going to sub our answer into equations 1 or 2. In this case, it's going to be equation 2. We're going to calculate the remaining coordinate of the POI. In this case, it's the x coordinate of the POI. And then we're going to do a therefore statement, stating the point of intersection actually is -6. So the point of intersection is 0, -6. And we did our therefore statement. So we're going to subtract equations 1 and 2 to eliminate the x variable. So we subtract equation 1 and equation 2 to eliminate the x variable. We isolated y by dividing out -2 to get y by itself, or the value of y. And y equals 7. So this is the y coordinate of the POI. And so we're going to choose the original equation 1 or equation 2. In this case, equation 1. And we're going to substitute y equals 7. So, to substitute, we substituted the y coordinate of the POI, and then we followed order of operations to solve for x, and to get the x coordinate of the POI. And then we're going to do a therefore statement. 3, 7. The point of intersection is where two lines or functions cross and intersect. So it's two lines crossing, and it's the point of which they intersect, hence the point of intersection. So we're going to subtract equations 1 and 2 to eliminate the x variable. And we divided both sides by 2 to isolate y, solving for the y coordinate of the POI, which is -1. Then we choose either equation 1 or equation 2 to substitute the y-coordinate of the POI to solve for the x-coordinate of the POI. In this case, equation 1. So we followed order of operations to solve for x, and the result being the x-coordinate of the POI, which is 0. So, we subtract equations 1 and 2 to eliminate the x variable. We isolate y to solve for the y-coordinate of the point of intersection, and then we substitute our result into equations 1 or 2, in this case equation 2. In this case equation 2, so we followed the order of operations to solve for x, and we got the x-coordinate of the POI. And then we have our therefore statement, which is the POI is 0, 0. So, explain how to solve this linear system, written. So this is question 6, H, and we are going to solve this and write it out. So we have a linear systems of equations, and we need to have the coefficient of x match each other so we can solve for the value of y, or the y-coordinate of the POI. So we need to multiply both equations by a number so the coefficients of x match. In this case, the lowest common multiple between 3 in equation 1 and 2 in equation 2 is 6. So that's the lowest common multiple. So we multiply equation 1 by 2 and equation 2 by 3. We then multiply the entirety of equation 2 by 3, so we are left with now we have a matching coefficient with both equations and can solve by elimination. So we eliminate one variable to find the value of the other variable, and then we substitute the answer in either of the original equations 1 or 2, and then you have the point of intersection. So we subtract equations 1 and equations 2 to have the result of 0x in the y variant, and then we have negative 23y equals 23. So now we divide both sides by negative 23 to find the POI coordinate, or the y coordinate of the point of intersection, which leaves us with y equals negative 1. And then we substitute y equals negative 1, the y coordinate of the POI, into the original equations 1 or equation 2 to calculate the x coordinate of the POI. So substitute y equals negative 1 into original equations 1 or original equation 2. So the original equation 1 was 3x minus 10y equals 16. So I substituted y equals negative 1 into equation 1, the original equation that we were given, to get the point of intersection x coordinate. And now we have our therefore statement to finalize the POI value. And that is our point of intersection for our last question. So thank you very much for watching. I hope you found this helpful, and I'll see you later.